talk about the idea of image degradation and restoration. So suppose that if I have an image f of xy, I'm calling it as the input image. Okay. Now suppose that you are going to capture an image with your camera. Then while you are capturing the image, you suddenly moved the camera so that the output image is kind of blurred. So that kind of blur is called the motion blur. So such things can happen. So such things can be modeled with a mathematical function as the degradation function. Then it can also be written in the spatial domain as h of x comma y, where this h is the DFT of this small h. So you can apply the function f of xy to uh, a certain degradation function h of x comma y. So when you have f of xy in spatial domain and h of xy in spatial domain, the output after applying this degradation function will be, you have f of xy, then you will be performing, or we will have to perform the convolution operation, which I am representing using a star symbol. Then you will have the function h of x comma y. Then at the output of this one, we are adding some more degradation, that is the additive noise. So this noise, I am writing it as eta of xy. So this additive noise can be produced due to some inaccuracy or some problems with the image sensor. So that can be modeled as a additive noise with the function eta of xy. I'm calling it as additive noise because we are actually adding this noise into my degraded image, or this image after this operation. I'm not multiplying, then it will be a multiplicative noise. Then this image after this entire operation will reach at this point. There we call it as the degraded image, or I can write it as using this symbol g of x comma y. So g of x comma y, or the degraded image, is essentially f of xy convolution h of xy plus the additive noise beta of xy. Then in Fourier domain, I can write this one as uh, I can write it as capital G of u comma v equal to, this f of xy can be written as capital F of u comma v. This convolution operation will be a multiplication operation, and h of xy will be capital H of u comma v plus this eta of xy, I am writing it as capital N for noise, n of u comma v. So this is the same degradation process written in Fourier domain or in the frequency domain. Okay. So in a degradation process, we have a degradation function and an additive noise. In certain instances, this h of xy can be an identity function, which means that there is no degradation function applied, and there can only be additive noise, where you are just considering some problem with the image sensor or some environmental conditions. So the such things can be modeled as a noise function eta of xy. Now there are two terms. One we called it as the image restoration, and previously we have seen certain term called image enhancement. We used certain techniques with spatial filtering and contrast stretching and image averaging, etc. So what is the difference between those processes and an image restoration? In image enhancement, such as contrast stretching or image averaging, what we looked at is it is actually a subjective process. We are not dealing with any kind of mathematical quantity which will say that the image is perfectly enhanced or something else. Or it also focuses on the appearance of the image to the viewer. The viewer is the final judge who determines whether the image is good or bad for a specific application. But in the case of an image restoration, it is actually an objective process. We can actually quantify whether the image restoration is better or not. And we also need some prior knowledge about the degradation function and the noise. That is, the prior knowledge about degradation function and noise will determine the output. Because that you can see that if you just mathematically find, if you just want to take out this quantity, that is f of uv, what you have to do, you have to subtract the noise from g of uv, and you can have to divide this function with h of uv. So if you want to get f of uv, then what will happen is, what you need is, you need to get this exact information about h of uv, and you need to get the exact information about n of uv, or h of xy, or and eta of xy. If you have the exact information about these quantities, then you can actually mathematically get the value of f of uv or f of xy. Then after restoration, you will get the f hat of x comma y, that is actually the restored image. So you need the f of xy look exactly similar to f hat of xy. If you want that, then you need to get the exact information about f of xy as, sorry, you need to get the exact information about h of xy and eta of xy. So the prior knowledge of the degradation function, that is h, and the prior knowledge about noise function, that is eta or n, will determine the output. There was no such thing when we discussed the image enhancement processes, such as image uh, enhancement using contrast stretching, or applying some basic spatial transformation techniques. That is actually, the viewer is the final judge who determines the image is better or not, but we have certain mathematical quantities which will determine the enhanced image or the restored image is good or bad. This is the basic idea of image degradation and restoration processes, and I will talk about these topics in detail in the upcoming videos. Thank you.